Okay. That's not recording me, it's recording you guys like talking. So I'll have to be loud. Okay.
Mr. Raymond,
Yeah.
you said we can retake the test?
Yeah.
Are you gonna have the same concept of problems, or is it just gonna be a whole different problem?
That'll be similar problems, but not exactly. Okay,
Yeah.
mass 1, let's get going, guys. Mass 2 falls over pulley. If mass 1 is greater than mass 2, what direction is it going to accelerate?
Mass 2. Wait, which one? Mass 1, sorry. I was like, which
Yeah,
one?
it's going to accelerate down to mass 1, right?
Yeah, that's what I
Okay,
meant.
so this one is easy in the sense that it's one-dimensional. You got the sum of the forces. We can just say it's the y. It doesn't really matter because there's only one. Do the forces cancel out on this problem?
No.
No, they don't. So the sum of the forces equals ma. But here's the trick. It's the total mass of the system, right? So it'd be m equals m1 plus m2.
Bye, my loves.
Bye.
Bye, Lexi. I love you.
Bye, darling.
Bye, sweetheart.
Bye.
Bye.
So then, does that make sense? Because this is the total mass of the system and the acceleration of the system. Yeah.
What was M1 and M2? The actual number?
It's this one was
10 and 7.5.
10 and 7.5 kilograms.
So,
Okay. So the sum of the forces would be mg. The positive one, we'll pick the heavier one. So we'll say this one is the heavier one. So m1 g minus m2 g, because they're fighting each other, right?
Oh, and then would it be over M1G plus M2G?
Yeah, because we have to sub, this is the total mass, so we have to sub this in here. So we'll call this equation 1, and this equation 2. So we gotta sub 1 into 2. Solving for A is just this. This one was, yeah?
I got that from the book. Or did
Yeah, I
you-
figured some of you guys might find something like that in the book.
yeah, no fair.
Should've passed it around.
We didn't go over that during the.
No, but if you use the sum of the forces, you can find it.
What was my notes?
We know for one that looked like this, right?
There was one on the table and there was a pulley, right?
Like that. We went over one like that.
See, that one made more sense to me, I don't know why.
This was straightforward, probably because the reason why it was you weren't looking at whether it was accelerating or not. With this one, it had acceleration, so you had some leftovers. And the sum of the force didn't equal 0. So does everybody get it?
Can you explain what you did for M of T? Like,
Yeah, I substituted it in, so it's A.
Like, how'd you get it? Like that?
Oh, it's the total mass, because since these two things are tied together,
Yeah.
it's got to accelerate together.
And you said that they're fighting each other, so that's why you subtracted M2 from M1.
Yeah, they're fighting. Yeah, the force of gravity on these two are fighting each other. Yeah.
Do you have the test papers?
The test paper, like your test paper.
No, any test papers. So I can do the problem.
Yeah, I think I might have one. It's the last one I have. Yeah. I'm sorry.
They finished reading.
No, I was debating, should I fool with this and get this going so I can record it and put it up on YouTube for the ladies that we're gonna have to take off, or grade the test. So I'll grade the test later. Sorry. Yeah.
What if we put M1 as 7.5 and M2 as 10? Because in the problem it first says 7.5 and 10.
It would be the same answer.
Okay.
Yeah.
But
would
it
just
would be going to the right.
Yeah, it depends on how you called your axis. If you said this side is positive and this side is negative, or the other way, it just the sign flips, that's all. Okay? Any other questions on this one? No?
So the answer would be like 1.27 or something.
Yeah, the answer was, yeah, 1.27 was the answer.
I think that's correct. I think I'm 1.4.
That's a pretty big number.
You get the 5 months.
But it wasn't hard, right? Now that you see the solution? No, it wasn't.
Well, I knew there was some formula, I used the wrong formula.
It's hard when you have to come up with what the
I
heck
was
to do on
confused,
your
I
own.
don't know.
Yeah, you get better at it as the year goes on.
Hope so.
What was mine?
Okay, now the next one,
Raging.
you had a ramp and a block of wood. You're given the mu sub k as 0.35.
I think I got this.
And you were asked,
30.
you were just simply asked, how long does it take to slide to the bottom?
The angle is 30.
Okay, I'll show you.
Yeah.
Is that 0.35?
Yeah, it's 0.35. So, yeah,
So after you find the components, or the sum of each side or whatever, you have to use one of those, right?
yeah. But it's the acceleration is not gonna be the acceleration of gravity. It's gonna be,
It's gonna be whatever you get with your summation thingies, right?
yeah, it's gonna, exactly. So, let's pick our axis to tilt. This is x, positive x, and this is positive y. So the sum of the forces in the x, is there gonna be leftovers? Is it gonna be accelerating?
Yeah.
Yeah, so we have to put MA,
Was this the one where it moved 4 meters?
huh?
Yeah.
This is the one where it moved 4 meters, right?
No.
Yeah, 4 meters. And then this equals, the positive force that's along the x-axis. Let's draw our forces before we get into this so we don't screw up. We'll put this 30 degrees down here. This is mg. This is the force of friction. This is the normal force. And there's nothing
There.
on that side. So,
And-
in the
okay.
positive direction would be, and then a minus, it would be, this is gonna be signed because remember, you gotta be careful of these funky, angles. This angle that the,
And A would be?
this one. This is the congruent angle to this. You guys see that? This is where some people get screwed up where, this angle matches this angle. Does everybody see that?
Yeah.
Okay, so then this is not gonna be cosine x, like normal. Normally the cosine is the x component, but in this case it's gonna be the sine. mg sine of 30, which I picked that because it's just 1/2. Makes the math a little easier. So there's that. And then we got to sub in for the force of friction, but you get that from the other equation. Sum of the forces in the y. Is there acceleration in the y direction?
No.
No, so we put 0 here. Then the positive would be the normal force. And the negative, it's minus mg cosine of 30. And then then it becomes really easy, from here, yeah. Because in your original equation is the force of friction,
Equals u sub.
mu sub s times the normal force. If this is equation 1, 2, 3, sub 1 into this guy right here. Or actually, it'd probably be easier to sub it into here. It'd be cleaner mathematically. So you could just put this as u sub s times f sub n, then you could solve for this. Since this is 0, f sub n just simply equals mg cosine of 30 you can plug this back in here,
So u sub s, u sub k.
so then it's mu sub s
I don't know.
equals
How do you K?
mg,
That's fine.
you're right. Mathematically, it works out the same.
Cosine
Cosine 30
minus
minus mg
sine
sine of 30.
And you cancel out the m's, right?
Yeah. Yeah, that's why I didn't give you the mass, because they're gonna come out in the wash anyways. And all this equals the mass times acceleration.
And then you get your acceleration.
I think I got it right.
And you didn't even have to do any other algebra that cancel out the mass to get your acceleration. Then once you have acceleration,
You just plug your.
I made it real easy on myself. It started from rest, so I used equation 2. It's just simply 4 meters times acceleration I got in part 1 times 2. Take the square root of that. That's the answer.
I don't know which one I put, yeah.
I mean, you can use number 1, but it's just more steps. If you use number 2, it saves you some math. And let me write that solution over here. And this is for the people that are watching the videos. This is from the canonical motion equations. And I just put 4 meters in here. Acceleration goes in here. This is 0 because it was released from rest. You solve for v.
That's it.
And I got, oh, actually, well, that's right, we were looking for time,
Yeah.
not velocity, so, duh. That's, if you were asked for what's the final velocity, that's how you would do that. I just
So
remember
you
looking
need
for
to get
time.
your
I
velocity.
knew I did number 1.
Number 1.
No, even easier, number 3.
Number 3, I could have used it.
Yeah, we don't know the
One next
velocity
to the
though.
one.
Oh,
Number 1.
The one right next to.
you're right,
Yeah.
so just use, yeah, you could just use, delta x equals 1/2 a t squared, and the
Why
acceleration.
did I not use that formula?
Ah, I got it right. In your face. I probably tried.
Yeah.
Point, and I got 2.28 seconds.
I think that's where I got the answer wrong.
I think,
I
I don't know
have
what I
like
got.
1.7.
I think it's somewhere around there. I hope it is.
Now, the reason why I stepped these up a little bit, because these are the nature of the problems you'll get on the test, on the AP test.
1 and 2 were kind of easy, but the last one.
Oh, see,
I got
third
one wrong.
was the easiest to me.
You just use the range formula.
But then I didn't know how to use the like use of k given or something or whatever.
I was trying to do the whole like summation, and then I didn't have time to try to find what to put into the range, unless I just put the range.
I just use the cheater range formula.
It's only.
But then like you gotta do
No, that's the last one you can use the
Yeah.
range formula.
Yeah.
Yeah, that's what we're talking
Oh, you're talking about the last one?
Yeah.
Yeah, I solved in 2 parts. The way I solved it was 2 parts and plugged in the range formula. And I tried doing it the other way, and it both worked.
Yeah.
So, I tried it both just to make sure I didn't do
I had time
something.
at the end, so I went back and did like the long way. It was the same thing.
I think you got that one, Will. Did you get it?
The third one? Yeah.
Did you get it?
I got the third one right. I just did the 2 easier ones right. Wrong.
Was the third one just the range formula, or had more to
What?
it, right?
The third, yeah, there was, because you had to find out the initial velocity.
Yeah, let's do it.
Like I made it 2 parts. It's basically 2 problems in 1 problem.
You find it deep.
Yeah, that's what I knew I had to do, but like I didn't have time to finish.
Man, I found the velocity.
And then you do 4 formulas.
See, I could have done it. I could have done it.
Mr. Mary's guys, I'm not sure that's my 2. I did wrong one 2.
Yeah, in a minute, I haven't rated, so I'll have to like give it to you, you'll have to look at it with me right now.
Oh, okay. Yeah, that's fine. I just want to got wrong.
Yeah, let me see, let me change all the right answers.
No,
Okay, you guys wanna see the last one?
Yeah.
We have time.
No, I don't got that one right. But. Oh, Mr. Mary's, put my grade check up there. Around the corner.
Great check. Oh, okay, in a minute, I'll take care of it. Okay, like I said, let's break it up into 2 problems. Let's just worry about the eraser first, and what velocity will it have here, so v, and we'll call it v sub naught, even though it's really v final. Cause this is the origin. This is what we don't know. We'll call this v C, V cardboard. So that's a V or V sub 0 cardboard. we're given that information. It's B sub 0, C equals 5 meters per second. The slope is 30 degrees. The mu sub k equals 0.32. And this ramp right here, we'll call this length equals 0.3 meters.
Will
Okay.
they give that all that to us?
Yeah,
Okay.
that's all in the problem. So what you need to do, given the mu sub k, is find out the deceleration of the block, right? So some of the forces, let's go ahead and gangster lean our forces here.
Mr. Gaines, what is V sub naught?
Huh?
Oh.
These are not like a cardboard. It's
Yeah, that's the initial, speed, when, on the cardboard, and we'll call this V sub naught because we're gonna use this for the other problem.
Oh,
Yeah.
I shouldn't have about the number, never mind.
Cause like I said, the easiest way to do this is make this into two problems. So what you need to do is just solve for this, and then it's just a range problem, which is real easy. Okay, so here we go. Some of the forces in the x, do they equal 0?
No.
No, they don't. There's some deceleration, so it's gonna be MA. Then you'll have the force of friction, it's fighting you in this way, so we'll put negative, force of friction. And what else is fighting you? Gravity. But it's not pure mg.
What?
I keep drop. It's not pure mg because I tilted my,
Yeah, it's gonna be cosine.
yeah, it's gonna
or
have,
something, I don't know.
it'll be,
Cosine,
well, you gotta be careful with it.
right?
Not necessarily. Is this congruent? This angle that I drew here and this angle here?
Maybe. Yes.
Yes.
Yes, so it's gonna be the sine, because the opposite is gonna be in our x over here. Remember, for when you start tilting these things, your signs can flip.
Which one's the Jason? Or what'd you say?
The x is the opposite, so we have to use sine on it.
Yeah.
Yeah. So then it's minus mg sine, and I wrote that really small, let me. Equals minus, or that's mg sine theta. So that's going down, this is force, normal force, and the force of friction is going back like that. Minus the force of friction. Okay. You know this equation, the force of friction is mu sub k times force of n, the normal force, and to solve the normal force, you need the y coordinates. Is there acceleration of y? Nope. So then it's, and the positive is f of n minus mg cosine theta, and is that it?
Yes.
Okay. Then this you just solve just like the other one. So f sub n is going to be equal the normal force. Oh, I'm sorry, the force of friction equals mu sub k, and this is going to be negative mg cosine theta. Any questions on how I got that? No, this becomes positive, because we moved it on the other side of the 0, so little mistake there. Okay, now we're gonna sub this, if this is equation 3, or 4, because this is our original equation. 1, 2, 3, 4. We sub 4 back into 2, this turkey goes into here. Huh?
What'd you say?
Just turkey.
So negative mg's theta.
Yeah, so acceleration is gonna equal, they're both negative, which makes sense, the acceleration should be negative, mg sine theta minus,
U sub k,
yeah, u sub k
mg,
mg
cosine theta.
cosine theta. You can actually divide out the masses. So then you wind up with equation 5, which is where I went, actually plugged everything in and got a value. And my acceleration was minus 0.762 meters per second. That was my acceleration. And then, I'm given the distance, and that's where I went back and used, from our canonical equations, we'll call it equation number 6. V squared equals V sub 0. And then since this is a negative, I'll put negative 2 times 7.62 times the distance, which was 0.3. So then I just, that's supposed to be squared. So I just, this is 5, so that's 25 minus this. And that resulted in, did I write it down? Was 25 minus 4.6.
Wait, is that a 2x for 2 times?
Yeah, it's 2 times.
Then isn't it negative 7.62?
This becomes 4.6 is what I got.
Oh, isn't it the acceleration negative, so,
Yeah, that's why this is negative.
oh,
This would have been a positive from the canonical equation.
okay.
But it become negative because the 7 was negative. So then it's V equals the square root of 25 meters squared, second squared, minus 4 what did I do? 4.6. And that gave me a new velocity of 4.52 meters per second. So it didn't really slow it down that much.
Yeah.
And then it's just a range problem. Then you
Plug
just,
into the other.
yeah, you just plug it into range equals sine of 2 theta over gravity. And you know, this is V sub 0. Actually. Is that the V sub 0? So not too bad, huh?
No.
Is that thing still recording? Yeah. Probably a huge file.
I see 3 of you.
So that's it.